Hello and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread we'll be discussing the Grade 5 Common Core Standards for Numbers and Fractions B.4.A, which involves multiplying a fraction or a whole number by a fraction. There are two examples given in the statement of the standard. One of them multiplies a fraction by a whole number. This same idea was discussed as a grade 4 standard, and there should be a link at this slide to a thread which discusses this idea in detail. So in this thread, we'll discuss multiplying a fraction by another fraction and creating a story context for a mathematical equation. The learning goals for this standard involve creating a story context for a given mathematical task, visualize and understanding the multiplication of a fraction by another fraction, and using multiple strategies for this understanding. We'll use area models, number lines, and symbols. Students will also communicate mathematical thinking with precision and, of course, accurately. So here's a problem. Create a story context for the equation 2/3 times 4/5 equals 8/15 and use various strategies to show the meaning and result of the required multiplication. Of course, the story context that people create can be anything. Here's one. Tina and her two friends share 4/5 of a pizza. One of her friends has no money, so Tina agrees to pay her share. What fraction of the cost of the pizza does Tina pay? Use an area model to begin. What's important to watch out for in these word problems that the students make up is that they do result in the operation, the mathematics that you want them to. It's not as easy as it might seem to construct a story context for a problem, but it's a really good practice for the student to do this. So we'll start out with an area model. We're looking at cost of pizza. So if we represent the cost of the whole pizza as this rectangle, then 4/5 of the pizza is what they're actually going to end up paying for, 4/5 of the cost. So we represent that by these 4 bars, which are 4 out of the 5 bars. So this is now the new kind of whole. The part that we need 2/3 of is this 4/5. So we need to break the 4/5 into thirds like this so that we can then look at 2/3 of the 4/5. So 2 out of the 3/3 of 4/5 of the pizza. And now we want to start looking back at the cost itself and look at now what part of the cost of the whole pizza does this area, this dark green, represent. So to do that, we want to break the rest of this pizza conceptually into parts that are the same size as these parts here. And those parts, if you look at them, there are 3 of them this way and 5 of them this way. So these are 15ths. And we'll break this top part into 3 more 15ths. So we have 15ths, or these little small rectangles. And the part we're interested in, the dark green, is 2/3 of the 4/5, that is. We want to know how many 15ths of the whole, what part of the whole is that, and so we can count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of these within the whole pizza of 15, so this represents 8/15ths of the whole. So Tina's share is 8/15ths of the whole. And what the student has done basically is multiplied 2/3 times 4/5. Here's our problem again. We'll create a story context for the equation 2/3 times 4/5 equals 8/15ths. we'll be using various strategies to show the meaning and result of the multiplication. We'll use the same story problem that we used before. Tina and her two friends share 4/5 of a pizza. One of her friends has no money, so Tina agrees to pay her share. What fraction of the cost of the pizza does Tina pay? Presumably the students will recognize, or need to recognize, that Tina and her friends are only paying for 4/5 of the total pizza. In any case, in this example we will use a number line for our strategy. So we begin by representing the whole pizza as a segment on a number line from 0 to 1. Since Tina and her friends will share 4/5 of this and pay for 4/5 of this, we need to divide this pizza into 5 equal parts and consider 4 of those, which is the amount of pizza that her friends will share and pay for, 4/5 of the pizza. Now the student needs to do some mental gymnastics and recognize that Tina is only going to pay 2/3 of this blue. So there's a new whole involved. We want 2/3 of 4/5. So we have to kind of conceptually think of the 4/5 as a new version of 1 of the whole, because this is what Tina is going to pay 2/3 of. And in this case now, we have to break this new whole, which represents 4/5, into 3 equal parts, and Tina will pay for 2 of those. So this is the portion of the pizza that Tina will pay, 2/3 of the amount that they shared, or 2/3 of 4/5. Now the student needs to revert back again. It's doing the previous thing in reverse, and consider then what part of the whole cost of the pizza, of this whole, is this yellow part. And so really what we need to do is find where on this top number line does this 2/3 line up. To do that, the student needs to recognize, since we're basically going to be breaking 4/5 into thirds, we can do that by breaking each of these segments into thirds, and like this, and ending up with 15 parts. So we've broken each of these 5 parts into 3 parts, so we now have 15 parts, and we can rewrite these fractions then of the whole pizza as in 15ths. Our 1/5 becomes 3/15, 2/5 becomes 6/15, and so forth. And now by filling in the rest of the 15ths, we can see which one lines up with 2/3, and we'll see of course that 8/15 lines up with 2/3 of this 4/5. In other words, Tina's share, this yellow, is 2/3 of the 4/5, but it's 8/15 of the whole pizza, and therefore 8/15 of the cost of the whole pizza. Here's our problem again. Create a story context for the equation 2/3 times 4/5 equals 8/15 using various strategies to show the meaning and the result of the multiplication. We'll use our same story problem. Tina and her two friends share 4/5 of a pizza. One of her friends has no money, so Tina agrees to pay her share. What fraction of the cost of the pizza does Tina pay? The strategy we'll use here is just a procedure. The key idea in the problem is that Tina is going to pay 2/3 of 4/5 of the cost of the pizza. Students need to read the problem carefully to understand that Tina and her two friends, the 3 of them, will share 4/5 of the pizza and pay for only 4/5 of the pizza, and that Tina is going to pay 2/3 of that amount. Mathematically, what we need to do is multiply, and students need to know procedurally that the word of means multiply. 2/3 of something is a multiply, so what we need is 2/3 times 4/5. This is a fairly straightforward multiplication. The other piece that they need to know, the fact and the procedure they need to know for multiplying, is that they multiply the numerators independently from the denominators to get the answer. And because there are no common factors in any of the numerators or denominators here, it's a straightforward 2 times 4 in the numerator gives you 8, 3 times 5 in the denominator gives you 15, and we have our answer that Tina will pay 8/15 of the cost of the pizza. So here's an example of some teacher work for this problem. Kelly signed up for a race that was 2/3 of a mile long. Kelly was only able to run 4/5 of the race when he got a cramp. How much of the race did Kelly run? There are two subtle things in this problem that are worth pointing out. The first is that the question is written incorrectly. If you read it carefully, it says, how much of the race did Kelly run? Well, the answer to that is given in the statement of the problem, because it says Kelly was only able to run 4/5 of the race. So the answer is right there. What was intended here is to ask the question, how many miles did Kelly run? Notice the distinction there. It's very important that the students read the problems carefully, and when problems are constructed, the questions are carefully thought through. The second issue here is subtle. It's not incorrect, but if you read the statement of the problem up here that we're trying to mimic, we have 2/3 times 4/5. This is generally considered as 2/3 of 4/5, whereas the statement of the problem here, that Kelly is running 4/5 of 2/3 of a mile. So correctly, the person who constructed the question wrote, what is 4/5 of 2/3? That's what's being asked in this question. Now, because of the commutative law of multiplication, it doesn't matter which way this operation goes, so we're going to get the same answer, and it's not going to change our interpretation of things. But it is a subtle confusion that students might have. They might say 2/3 times 4/5 is not the same as 4/5 of 2/3. It is, but because of the commutative property. In any event, we have an area model up here which begins with 2/3 of a mile. So here's a mile this way, and 2/3 of the mile is going to be this much of it out of that mile. So there's your 2/3 of the mile. And then out of that 2/3, the 4/5 of that is going to be this portion, 4/5 out of the 2/3. And then conveniently, the person just drew these all in squares on a grid and was able simply to count the grid squares and got 8 out of 15 grid squares as the total. So this large rectangle, it represents 1 mile, and the 8 out of 15 parts represents the amount that Kelly ran. We've also got a number line version of things here, where the 2/3 of the mile are given up here. Here's the whole mile. And then, as we did in our example, now we're going to look at 4/5 of this 2/3. So we make this the new whole, divide it into fifths, and find 4/5 of it, which is here. And now going back to find out how much of a mile is that, because the mile is here. Here's the full mile. We find that it's 8/15, as we had shown before. So here's some mathematical writing that we might expect to get from a student in this problem. Of course, there's a wide variety of story contexts for this problem. The main thing is to make sure that the question is properly asked and the correct information is given, so that it ends up with 2/3 of 4/5 or 4/5 of 2/3. We're doing it the former way, so we've got our whole is 1 here, and there you see a model, and the student has identified 4/5 of that model in the orange to represent that part. And then you can see the writing here, they recognize that they need to break 4/5 into thirds in order to get 2/3. So what they do is split each fifth into 3 parts. So here you see the 3 parts in each fifth, 1, 2, 3, 1, 2, 3, and so forth. And they recognize that this gives us 15ths. The next thing they notice is that 4/5 is 12/15. That's this 4/5 is equal to 12/15. And now we're going to break it up differently since we want 2/3 of 12/15, and the units are 15ths. We know that 1/3 of 12 is 4. Here's 1/3. So 2/3 of 12 is 8. And again, since the units are 15ths, 2/3 of 4/5 is then 8/15. You'll see once again that the student has shown here an image to represent a concept, brings in a few facts, and what's really showing here is the language. And it's, again, it's not just the mathematical language, it's the language of communicating what you're doing and what you're thinking, and that's well done here. And ultimately, this really shows the understanding of the procedure, which could have been basically written straight up just like this, which is what you'll often see from a student.